So that is sense in Alpine. We can. So what we can, everybody is watching the different video. Please watch yourself. Once in a while, watch yourself. 3, 2, 1. All the way.
Hello, everyone. Welcome to tutorial. I am Mr. Olukwe. I'm software developer at EdSofta, and I also do JAMB tutorials. And I'll be taking you on your JAMB tutorials lecture. So EdSofta. So we'll be taking these 5 topics: AP and GP, swords, circle geometry, sets, equations, quadratic and simultaneous equations. We'll be looking at the various ways to handle and tackle these topics. So EdSofta is the tutorial is powered by EdSofta. EdSofta is an edtech company. Basically, we're an educational company that uses tech to power our education. So we do apps, various apps for JAMB, for WAEC, name it. But this tutorial is targeted at JAMB students since their exam is soon to be starting. So we're looking at EdSofta is an app that prepares students for JAMB UTME. It has past questions, study materials, and many other features that help students prepare for the exams. Yeah, for this tutorial, we'll be solving questions from the EdSofta app. You can visit Google Play or your Android phone, search for EdSofta UTME and install it. Also, you can go to our website at www.edsofta.com. If you have a Windows system, you can download for Windows and install and activate it. Thank you very much. So we'll take lectures, we'll solve some questions, and also we can also take questions from you. Feel free to comment on the search, comment on the live, and whatever questions you have will be taken. So first, we'll be looking at AP and GP. First, I want to talk about a few things. That's AP and GP is a topic that actually arises from the topic sequences and series. And sequence is just, let me just move forward a bit. You can see sequence is just where you have a list of numbers that are connected by a particular pattern. So let's say the multiples of 2. So you have 2, 4, 6, 8, 10, 12, 14, 16. Now these numbers are connected by a particular pattern. That's they're increasing in 2s. That's a sequence. So it's just moving in that pattern. So they are moving consecutively in that pattern. Even your numbers from number 1 down to 1000 down to infinity is a sequence of numbers, because what is common between each consecutive number is the difference of 1. So now, while it's called sequences and series, because they are practically related, but when we talk about series, it's just when you, instead of just listing the numbers, so you take, for instance, you put 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. If you just write the numbers, that's just a sequence. But when you want to form a series, you have to indicate that there's an addition of those numbers. So that's where, if you go deep into further maths, go deep into some other mathematics, you hear things like Maclaurin series and Taylor series. That's just, they are all sequences, but this time they're not just listing out the sequences, they're adding the sequences so that it can help them to solve some other mathematical problems. So first, there are 2 types of progressions, or there are 2 types of, from the word progressions, it means increase. There are 2 ways a sequence can increase. So it can either increase in an arithmetic way or increases in a geometric way. That's why we talk about arithmetic progression and geometric progression. Now, arithmetic progression is a type of sequence that is generated by the successive addition. Now, when we talk about arithmetic, we're just talking about 2 binary operations, that's plus and minus. So one is arithmetic, there's a successive addition of a constant number to the term to get each successive term. So a successive addition. So look at this: 2, 4, 6, 8. You are adding 2 to 2 to give you 4. You add 2 to 4 to give you 6. You add 2 to 6 to give you 8. You have 2, and you just keep going on and on and on and on and on and on. That is arithmetic progression. It can also be the other way round. It can be, you can do, it can be a successive subtraction. So take for instance the second series under that, we have minus 3. So they are subtracting 3. 8 minus 3 is 5. 5 minus 3 is 2. 2 minus 3 is minus 1. It's just, yeah, 2 minus 3 is minus 1. Minus 1 minus 3 will be minus 4, and on and on and on. So that's just to explain the arithmetic progression. That's just to explain arithmetic progression. So you hear there's a particular man in economics. I can't really point out his name, but he was complaining that there was a problem, I think in Britain, or there was a problem in the world at that time, where resources were increasing arithmetically, but the population was increasing geometrically. So it's like, this one is faster than the other one. So arithmetic just means that it's increasing at a very small pace, but it's just a successive addition. You can't obviously compare addition and multiplication. If somebody tells you that they are going to be giving you every somebody that's okay, they are just adding 20 naira to his money every month, is not as rich as somebody that they are multiplying 20 naira by his money every month. That's just a way to just look at arithmetic progression and geometric progression. So another type of progression is, before I move to the formulas, is geometric progression. Now, geometric progression is a type of sequence which can be generated by successive multiplication of a constant number to a term to get each consecutive terms, and or successive division of a constant number from a term to get each successive term. So you look at examples I have here. The first one I have is multiplied by 2. So 3 times 2 gives you 6. 6 times 2 gives you 12. 12 times 2 gives you 24. 24 times 2 gives you 48. 48 times 2 gives you 96, and on and on and on as you go. And also, if you look at the second one, which I termed as a series, is 80 divided by 2 is 40. 40 divided by 2 is 20. 20 divided by 2 is 10. 10 divided by 2 is 5. 5 divided by 2, 2.5. 2.5 divided by 2, 1.25. 1.25 divided by 2, 0.625, and you go on and on and on and on like that. It's infinite. You can keep dividing, you can keep multiplying, but the sequence just continues to what? To increase. So that's just basically geometric progression and arithmetic progression. Now let me go back a bit so that we can talk about the different equations in arithmetic progression. So one of the equations in arithmetic progression is the first one. Tn is equals to a plus n minus 1d. Tn is equals to a plus n minus 1d. Now this is this is a very simple equation. What is saying Tn by that means the nth term. Tn by what we mean when we talk about Tn, we mean the nth term. The nth term. Please hold on. Okay. Okay. So Tn, if you look at what we had Tn is equals to a plus n minus 1d. Now from the slide, a is the first term, d is the common difference. Now this, mind you, this is a normal, a standard, this is a standard This is a standard sequence, a standard arithmetic progression. This is the formula for solving a standard arithmetic progression. So let's just take um, a let's just take a little an example. Let's take an example. So let's say we have a sequence. Let's say we have a sequence S. You say S is equals to 2, 3. No, let me not have 3. You say 2, 4, 6, 8. Now, obviously, if I ask you to get the next number, it is a bit easy because you can see that 4 minus 2 is 2, so you know they're adding by 2, so you know it's 10. But sometimes it gets a bit tricky and it gets a bit humongous, or the calculations get a bit large. That's why we need to have a formula so that it makes it easier for us. So let's use our formula and see if we can find the fifth term, because here we have the first term, which is 2. This is our A. We have our T2, we have our T3, and we have our what? T4. Mind you, our A is also the same thing as our T1. So let's say we are to find our T5. We are to find our T5. We would say that T5 is equals to A plus 5 minus 1 D. Because from our formula, we know that what? Tn is equals to A plus n minus 1 D. Now the question now is, what is our A? We know our A is what? Our A is what? 2. What is going to be our D? Our D will be what? T2 minus T1. And what is T2? T2 is 4, or better still, we can call this A so that we don't cause any confusion for ourselves. So we can call this A. So 4 minus 2, and our D is going to be what? 2. So we can substitute this back inside the equation, and what we are going to have is 2 plus 5 minus 1 times 2. And that's 2 plus 4 times 2, which is 2 plus 8, which is what? 10. Very correct. Very what? Very correct. So you can see that the you can see that this formula makes it easier for us to get. So if they asked us, for instance, they told us that we should find the T18, that's the 18th term. So instead of us to start saying we want to start doing 2, 4, 6, counting with our hands, which is going to take a whole lot of time, we can just, let me clean this off and let's rewrite it so that we can solve it. So we can just, just write it like this. You can just write it as T18 is equals to T18 is equals to A plus 18 minus 1 D. What is our A? 2. What is our D? 2. 18 minus 1 times 2. Now, this is 2 17 times 2, which is 2 plus 4, which we are going to have 36. So our T18 is 36. And you see, it makes it easier for us to be able to, just calculate. They can give us what is the 106th term, and we can just use our formula and come up with it. What is just name it. What is the 1000th term? We can use that formula to always calculate our AP, so long it's a standard arithmetic progression. So long it's a standard arithmetic progression. All right. So give me a minute. Let me show the slides back. Okay. Hope we can all see the slides. So if you look at the slides, there's another um, there's another um, there's another equation there. That equation is to find the sum of n terms of a series. That equation is to find the sum of n terms in a series. So to find the sum of n terms in a series. So if a series is 16, how do we find the sum of 16 terms? If a series is 100, how do we find the sum of the first 20 terms? We use this formula. So let's take an example. So let's just take an example and see how this formula can help us. Okay. Before I do that, I have to. Okay. So, all right. Okay. So the formula that we had there was Sn is equals to half n into bracket 2a plus n minus 1 n minus 1 So there's no need for us to go into the calculation of how this equation was found, but this is an equation to find the n terms. So let's take another sequence. Let's just take another sequence. Let's say maybe the sequence is sequence P. Let's say sequence P. And we say P is equals to 3, 6, and we say P is equals to 3, 6, 9, 12, and dot there. So since we can see 4, let's just say we want to find the sum of these 4. Now, naturally, if we are to find the sum of these 4, we have 3 plus 6 is 9. 9 plus 9 is 18. 18 plus 12 is 30. So we have, can just write it at the side. 3 plus 6 plus 9 plus 12 is equals to 30. But now let's see if our formula can give us the same let's see if our formula can give us the same sum. So let's say we have S4 is equals to half for 2 times 3 plus 4 minus 1. Now, again, how do we find our A? Our A is the first one. Our A is what? 3. And our D will be what? T2 minus A, which is 6 minus 3, which is 3. So we have D here also. So we have, so if we are to do it with board mass, we know we have to do the brackets first. So this will be 6 plus 9. So this will cancel this. We have 2 times 6 plus 9. Everything will be 2 times 15, which is going to give us 30. So we can see that this, equation works. So we can use this equation to solve various, so they can tell us that, okay, they can give us a series just like P, they can give us a sequence just like P, and tell us to find the sum of the first 30 elements. Now we can't go all the way doing 3, 6, 9, 12, 15, 18, 21 until we get to the 30th element. That's a long shot. When we can just use our formula to just find the, when we can just use our formula to find the sum easily. So we can just say S30 is equal to half times 30 into bracket 2 into brackets 3 plus 30 minus 1 into bracket 3. And that's all. And we compute our answer very easily with the formula rather than just saying that we want to start counting all the 30, start listing all the 30 members of the sequence, then adding them manually. You can see that these formulas make it easier for us to work around arithmetic progression. All right, let's move on to the geometric part and let's see what we have there. So just give me a minute. I'm going to switch the slides back to I'm going to switch the screen back to our slides so that we can go on from there. Okay, hope everyone can see me. All right, so we've talked about our geometric progression. We've talked about our arithmetic progression. We've looked at the formulas. We've looked at the two formulas, the formula for finding the nth element, and we've also looked at the formula for finding the sum of the elements. Now, these formulas are very, very important as we are going to look at some questions, and those questions need us to get and know these formulas. So let's move on. So geometric progression, as we said, is a type of sequence that is generated by successive multiplication of a constant number to a term to get each consecutive term, or successive division of a constant number from a term to get each consecutive terms. Okay, so if you see, can you see a pattern generated in each of the set of numbers? 3 dots mean that the pattern continues the same way. Yeah, so let's look at the formulas. Now this one is a bit different. Now we have two formulas just as we have for the AP. It's just that the way we find this one is different. And if you notice in the AP, the D is what we call the common difference. But in the GP, what we have is R, which is the common ratio. So in the AP, we have common difference. That's 2 plus 2 is giving us 4. 4 plus 2 is giving us 2. That's the difference between each successive term. They are called the common difference. But for GP, since they are not differences, they are more of ratios. So you multiply by 2, you multiply 3 by 2 to give you 6. You multiply 6 by 2 to give you 12. You multiply 12 by 2 to give you 24. You multiply 24 by 2 to give you 48. You multiply 48 by 2 to give you um um 96, and so on and so on and so on and so on. You keep going multiplying. Now that thing you are multiplying or you are dividing to give you the next consecutive member is the common ratio. So in this place we use common ratios, whereas in the other place we use what we call what um um whereas in the other place we use what we call um um ratios. So let's move on. Let's move on. Okay. So I'll switch to the whiteboard so that we can take some examples before moving ahead. So let's take the first one first. So we have a very simple, let's take for instance, we have a very simple AP, a very simple AP, a very simple GP to be. So let's call our GPS. Oh, sorry. So let's call our GPS, and let's say S is equals to, so let's see, use a very simple GP. 3, 6, 12, 24, 6, 12, 24, and that's it. So now for this, you have, this is a very simple GP, a very simple GP, where our A, as we all know it, is 3, and our R would be T2 divided by A. And what do we have? That will be 6 divided by 3, and that's what? 2. So our R is 2. Now for us to find the next term, so here, as we did in the first example, we have A, T2, T3, T4. Let's say we want to find our T5. Now, based on our calculations by looking at it, we know that our T5 is supposed to be 48. We know that our T5 is supposed to be 48. But let's see if our formula works. And our formula tells us that T5, Tn is equals to A r raised to power n minus 1. So that means we are going to have, therefore, T5 will be equals to, what's our A? 3. What's our R? 2 raised to power 5 minus 1. That would be 3 times 2 raised to power 5 minus 1 is 2 raised to power 4. That would be 3 times 2 raised to power 4 is 8. 2 raised to power 4 is not 8. That's a mistake. 2 raised to power 4 will be 16. 2 raised to power 4 will be 16. And that will give us 48. Beautiful. So if we're asked to find T18, as we did the last time, we can always, if we're asked to find T6, or if we're asked to find T6 or T6, or let's say T7 or T8, let's say T8, we're asked to find T8. All we have to do is this. All we have to do is this. 3 times 2 raised to power 8 minus 1. That would be 3 times 2 raised to power 7. What would be 2 raised to power 7? That's 2 raised to power 5, 32. 2 raised to power 5, 32, 64. That's 128. We have 3 times 128. And we have our answer. Very, 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 very we have our answer. We have our answer. Very, very simple. Very simple. Very, very simple. Very simple. We didn't need to go through all the whole stress. We just found our answer easily. So that's the importance of the formula. So with the formula, you can just easily just find the 8th term. You can find the 18th term. You can find the 17th term without you saying you want to start listing everything one by one, one by one, one by one. By the time you are listing everything and you're done, you just be tired. So these formulas help us to navigate through our arithmetic progressions and our geometric progressions easily and perfectly. So let's move on. Let's move on. Let's move on to the second set of formula. Let me switch back to the um to the slides. Okay. So the next one is the sum of n terms. The next one is the sum of n terms. The next one is the sum of n terms. The next one is the sum of n terms. So this one is just telling us that, okay, just the same way we had it for the just the same way we had it for the just the same way we had it for the AP, that's the same way we are going to have it for the G. We can always find the sum of the first 30 terms, the sum of the first 60 terms, the sum of the first 2 terms, the sum of the first 3 terms. Just an easier way for us to walk and help us walk through our AP and GP so that we can solve particular situations and particular problems that might arise in our mathematics. So let's move back to our whiteboard and see if we can take one or two examples. Okay. All right. So let's look at so let's start with, let's look at this example. Let's say our, this is our equation. So this is our sequence, and we want to find the sum of the first n terms. And we know the formula. We know that the formula is Sn is equals to A into brackets r raised to power n minus 1. Now note this n, this r raised to power n minus 1 is not the, is not up, it is minus 1, so that we don't make that mistake. It is minus 1. So note, it is not like this, it is not this, it is this, it is not this, it is this. Note, this is it, so that we don't make a mistake whenever we are trying to do it. That's why I'm reiterating that. All over r minus 1. So let's say we want to find the sum of these four terms. Now normally we know it is 2 plus 4 plus 8 plus 16. 2 plus 4 plus 8 plus 16 is, I think that sums up to 30. Wow, funny how they all sum up to 30. So we know S will be equals to, as we have it, what's our A before we jump? Our A is 2, and what's our R? Our R is T2 over A, which is 4 over 2, which is 2. That's what. 2 into bracket 2 raised to power 4 minus 1 all over 2 minus 1. So what do we have here? 2 raised to power 16 minus 1 all over 1, which is 2 raised to power 15, 2 times 15, sorry, all over 1, and that's what, 30. You see, we found the answer. We found the answer. Why? Because we're able to just use the formula. So if an equation arises or a situation arises where you are asked to find S30, you will not come and be doing it this way. Be listing all the methods, listing all the members, listing all the members. You listen all the members, listen all the members, listen all the members. You can't be listing all the members. You have to use what? Our what? Formula. Where you just put S30 is equals to 2 into brackets 2 raised to power 30 minus 1 all over 2 minus 1. By the time you compute your equation, your calculator, you have your what? Final answer. All right, so I think we've done justice to this topic. Let's just go over the slides again. Then to the we move to the class, the questions. We'll move through questions. Okay, let us move to this. So like I said in the beginning, we have a sequence, we have series, and I explained what sequence and series was. We also moved to arithmetic progression. We moved to arithmetic progression, we moved to GP, geometric progression. We looked at it, we looked at the formulas, and now we're going to look at some word problems, just some small word problems. Like we all know, and they all say in mathematics, you might be taught A plus B, 2 plus 2 is equals to 4. But by the time you see the questions, you start saying that they are testing not just the topic, they are testing previous topics. So everything is just mixing together. So we are going to see the thought process towards solving AP and GP questions. Like I said, It's not hard, or like I would love to say, it's not hard. It's just that we just need to just find a way. Just that we just need to understand that there's a thought process towards solving geometric progression or arithmetic progression questions. Okay. So let's just look at some of the questions on AP and GP. So the first question, the first term A of an AP is equal, sorry about this, is equal to twice the common difference, D. Find in terms of D the fifth term of the AP. So this is, now there's a thought process, everybody. Like I said, there's a thought process towards solving this kind of questions. So let's move to the whiteboard and see what we can do. So let me see if I can. Let me see if I can bring in the question for us here. Right? So that's the question there, so that we can see the question while we are solving it. Okay, so like I said, the first term of an AP, the first term A of an AP is equal to twice, is equal to twice the common difference D in terms of common difference D. Find in terms of D the fifth term of the AP. So in this case, let's say they are saying that we have an AP. They are saying we have an AP. So they are saying we have an AP. Let's say the AP, A, T2, T3, T4, T5. And they are saying the common difference is D. The common difference between every of the members of the elements of the sequence is D. And they are saying that A is twice the common, that means A is equal to 2 times D. Now everybody, you know that what? Tn is equals to A plus n minus 1d. Now they want us to find the fifth term, that's T5. So therefore, T5 will be equals to A plus 5 minus 1d. Now from what they said, A was plus what? 4d. But from the question, they said we should find in terms of d. Find in terms of d. That means the only thing that we should have in our answer should be d. The only thing that we have in our answer should be d. But we know that A is what? 2d. All we have to do is to what? Substitute. So we know that T5 will now be what? 2d plus 4d, and that will give us 6d. That's our final answer. It's a very simple question. The first term of an AP, is equal to twice the common difference. Twice the common difference. The first term of an AP is equal to twice the common difference. Equal to twice the common difference. The first term of an AP is equal to twice 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 the common difference. So the first term A is equal to twice the common difference. That's 2 times the common difference. And they now say we should find our answer in terms of D. In terms of D. In terms of D. That is why we have to substitute A here. For 2D, we have to substitute A for 2D. We have to substitute A for 2D because of what the question asked us to do. We have to substitute A for 2D because of what the question asks us to do. So this is a very simple question. A very simple question. If you see such questions again, you can easily just just look at them and and you can solve it. They can, once they bring out any other kind of, they ask for the sixth term, they ask for the eighth term, but they bring out any other type of this question, you obviously know what to do. All right, I'll give you just about 2 minutes for you to look at it, and so we can move on to the next question. Okay, I'm back. So let's move to the second question. So I'll be clearing off what's on the board now. So we'll be looking at the second question now. So this is our second question. This is our second question. And the second question says, the second question says that the common ratio of a GP is 2 if the fifth term is greater than the first term by 45. Find the fifth term. The common ratio of a GP is 2 if the fifth term is greater than the first term by 45. Find the fifth term. So how do we do this? How do we solve this? Very simple. First, we can write out what we were given. So we're given R as 2. And they said the fifth term is greater than the first term by 45. What this means that 12 is greater than 6 by 6 because 12 minus 6 is equals to 6. That makes sense, right? So the same thing will happen to our first, the same thing will happen between our first term, and so this will be simplified as this: T5 minus A is equals to 45. Now, somebody will ask, how do we solve this? Bearing in mind that we only have T5, we don't have A, we don't have T5. But let us not forget that we know that from our equation that Tn is equals to A raised to power Rn minus 1. So therefore, T5 will be A raised to power R5 minus 1, which is A raised to power R4 minus 1, which is A raised to power, sorry about that, which is A raised to power R raised to power 4, which is back to A raised to power what? R. So R is 2, so we can just substitute R here. So we have 2 raised to, so we just have 2 raised to power 4, which we can say is A raised to power, which is, we can say is 16A. We can say that, which we can say that what? T5 is 16A. T5 is 16A. We can substitute this back into this equation so that we have 16A minus A is equals to 45, which will give us 15A is equals to 45. And from our elementary mathematics, we know we divide both sides by 15. A will be 3. So our A is 3. And if our A is 3, we can obviously now find the fifth term. We know T5 is equals to A raised to power R5 minus 1, which is A raised to power R raised to power 4, which is AR raised to power 4, which will be 3 times 2 raised to power 4, which is 3 times 16, which would give us 48. Very simple. Or we could have just even said a very easy method. T5 since T5 is 16A, 16 times A, and that's all. And you see, it's very simple, but there's just a thought process. So my advice for anyone that wants to solve a question on arithmetic on AP and GP is that you must always go back to the formulas. You must always go back to the formulas. No matter what they give you, whether they don't give you A, they don't give you R, they don't give you T this, they don't give you T that. Always make sure that you go to the what formulas. Always start from the formulas, and you will see that the mathematical question will begin to open up, and before you know it, you have solved it. So always make sure that you go back to the formula. So let's move to something else. Let's move on to something else. We can rub this off and move to the next question. This is another question, and we are going to be looking at this question together. So they said if the seventh term of an AP is twice the third term, and the sum of the first four terms is 42, find the common difference. So they want us to find the common difference. If the seventh term of an AP is twice the third term, so first let's interpret the first statement. The first statement, let's interpret it. The seventh term is twice the third term. The seventh term, which will be T7, is equals to 2 times T3. This will leave us at T7 is equals to 2T3. And the sum of the first four elements is 42. So now, what they are saying is that S4 is equals to 42. Now, note, a lot of these questions always result in being simultaneous equation. They always result in it. But let's see, we can go on with it. T7 would be, so like I said, always go back to the formula. The formula tells us that what? Tn is equals to A plus n minus 1 d. So our T7 will be, sorry about that. Our T7 would be equals to A plus 7 minus 1d. That means our T7 will be equals to A plus 6d. Please let us all note this. While our T3 will be A plus 2d. Now, this was gotten from the formula. We don't have so much space, so that's why we have to, look, see how we can squeeze some steps. So we can substitute this into this formula. So instead of having T7 and T3, we can have, since we know T7 is equals to 2T3, we can have A plus 6D is equals to 2 into bracket A plus 2D. We can have this as our equation 1. Now let's go back and look at the S4. The S4, we know that S4 is what? Half into bracket 4. From our formula from the beginning, if you have been following, 2 into bracket A, we don't know A, plus 4 minus 1D. So this can cancel this. We have 2 into bracket 2A plus 3D. Like we said, we know S4 is 42, abi? So 42 is equals to 4A. I'm multiplying through 2 times 2A, 4A plus 2 times 3D. What do we have? We have 6. We have 60. So this is our equation. So now we'll solve the simultaneous part here. So look at this. So how do we solve it? We have 2 equations. First, we have A plus 6D is equals to 2A plus 2D. This can be written as A plus 6D is equals to 2A plus 4D. This will not be, we can collect like terms, or we can just take everything to one side. So we have A minus 2A plus 6D minus 4D is equals to 0. What I did was just to bring all this to this side. When you bring them to this side, they are sign change. So you have minus A plus 2D is equals to 0. This is our actual equation 1. While we also have 4A plus 6D is equals to 42 from this equation down here. So now, what we can now do is you can either use, there are 2 ways you can solve a simultaneous equation. We can either use the substitution method, or we use whatever method we like. But let's go with the substitution, or let's go with the substitution method. So how do we do it? All we just have to do is look at the first equation, minus A. We can say minus A is equals to 2D. That means A is equals to minus 2D. So we can substitute A here with the A here. And what we now have will be 4 into bracket minus 2D plus 6D is equals to 42. That is minus 8D plus 6D is equals to 42. What do we have? Minus 8D plus 6D, we have minus 2D. Is equals to 42. This means that our D is going to be 42 all over minus 2, which is equals to 21. Very, very simple. That's all. We're done. So I'm just going to use this red pen to highlight some points while explaining it again. So like they said, the first term of the AP is the 7th term of an AP is twice the 3rd term. So you see the 7th term is twice the 3rd term. That is what I represented here. Now, like I said, always go back to the formula. So from this formula, I was able to generate this, also generate this. With this, I wrote back this formula here so that what? I can substitute my A plus 6D and my A plus 2D for my T7 and my T3. That is how this equation was generated. Now, this equation is from our sum equation, which I can write down here since there's still space, as Sn is equals to half n 2a plus n minus 1 d. Can you see that? So that's this how this equation works. And what did I do? I solved the equation down to this point. I solved the equation down to this point. And I named this our equation 2, while I named this our equation 1. So I can remove this, put it down here. So I brought back this, okay. Still need it. I brought back this equation here. I simplified it. I brought it back to simplify it here, here, and I still brought back the equation 2 here also, so that we can solve our simultaneous equation. And I said I used the substitution method. I use the substitution method. During this lecture, we are also going to look at simultaneous equations. So if you don't really understand how the substitution method works, don't worry. By the end of the lecture today, you will understand how the substitution method works. So that's how I was able to, I said from this equation, if minus a plus 2d is equals to 0, if I bring 2d to this side, we have, wow, you can even see, this is supposed to be minus 2d, because if you bring plus 2d to this side, it becomes minus 2d, and this becomes 2d. So this becomes 2d, this becomes 8d, which will make it actually 16d, 14d, I mean. So that will make it so we'll have our answer should be 3 and not 21. That was a mistake on my part. So you can see we have our answer to be 3 and not 21. So like I was saying, you have so I substituted this, put instead of this a, I put what, my 2d that I have gotten, because I can cancel this minus will cancel this minus. I put my 2 button. By the time I put the 4 times 2, the 8d, 8d plus 6d, 14d, 42 over 14 is 3, and our answer to this is what? Is 3. And we find our common difference. So like I said, when solving all this equation, make sure you go back to the question. Make sure you go back to the question. Make sure you go back to the question. We'll soon be coming to 15 minutes. We're going to be resuming back in 15 minutes. So we're going to be resuming back in 15 minutes. So I'm just going to go over the slides one more time, talk about some of the questions that we answered, and then we so like I said, we did AP, GP, we talked about arithmetic progression, how it is in a sequence and you're just adding a particular common difference between the consecutive terms. We also talked about GP. We talked about how that is where you are multiplying or dividing between the consecutive terms. And we went through the formulas, and like I like to reiterate, every question that is on AP and GP, always make sure you go back to the formula. Always make sure you go back to the formula. So thank you for having me this few minutes. We are going to come back in the next 15 minutes. So please get ready. We are going to be taking swords we're going to be dissecting swords and opening it up so that we can all understand what swords is about. Thank you very much, and God bless you.